contractor to install that, because they'll probably install it based on what they're used to, which is high temperature boiler heat. And the in-floor tubes will be not spaced appropriately for low temperature heat. And then avoid, I talked about the forced air, avoid putting low temperature heat into forced air systems, because it will tend to have a cooling effect. And now I just want to restate, just because I'm talking about lower temperature doesn't mean I'm talking about lower heat flow into the building. If you get your emitters to work properly, you can still transfer large amounts of heat into the building at a lower temperature. This is the energy balance sheet for Ron's house. This is the one error that I was saying I think was on here. I think this number, if you make this one 22, I think the November line I checked adds up properly, but it doesn't make sense that it's 2. So this first column is space heat. I'm assuming that the values are kilowatt hours. So January, this looks like they want to have 782 kilowatt hours of heat, which works out to 25.2 kilowatt hours per day on average in January they want to put into this house. So,
can we go back to that slide?
Maybe.
Maybe not. So the PD there in January is 362 kilowatt hour.
Yeah.
And
which I think this works out to around, is it 13 or 14?
A day?
A day.
Yeah, okay, yeah.
Yesterday was 25.
Well, it's sort of in the ballpark, yeah.
Yeah,
Yeah.
if on sunny days it'll nail it, but January was 100. In January they produced 100. I have a slide of January's consumption and use numbers.
Well, these are long-term averages. Yeah.
Yes.
Yeah.
That's one problem in general with solar. Everything works on averages, average output, expected output, but you have to heat a home.
I think too, panels were covered with snow for a while, and it was a real sticky snow that...
I got the broom to clean off the panels about 2 weeks ago, but the first 2 weeks of January were actually really cloudy.
Yeah, if there's bright sun, the snow will come off within a day. There will never be 2 days in a row bright sun, and the panels won't stay covered. It's been my observation. So, ignoring the domestic water heating, we want to put 25.2 kilowatt hours a day into this house. And we were told that this 8-foot baseboard section was the mechanism with which to do that. So this is what they call a slant fin, which is a brand name baseboard heater. So this looks like maybe a 3/4 inch copper pipe with a bunch of fins on it, inside of an enclosure that looks very similar to this one that we have installed here. The one that we have installed is this one here. It's a Smith's HE2 8-foot baseboard heater. It has 2 copper pipes in it, and these aluminum fins are much taller. They go right from the bottom of the...
It fills the cabinet, basically.
Yeah, right from the bottom of the cabinet right to the top. So what's the difference?
And does the thin surface go right where there's perforations? Is that,
yeah, it goes past the perforations a little bit. Yeah. I think this is $250, was it?
No more than that. It's over 300. It's about 3 times the cost of the...
So 3 times the cost, but less than $500.
Yes.
For the only heat emitter in the solar. So if we're putting this 25.2 kilowatt hours a day into the house, if we're doing it constantly, it means we need basically 1 kilowatt every hour. 1 kilowatt hour into the house 24 hours a day in January to reach that target. And with the original slant fin heater, 8-foot heater, and I assumed a 1 gallon per minute flow rate, which is seems to be an industry standard, it would require the temperature of the fluid to be 71 degrees Celsius. Changing to this heater, we can achieve the same rate at 43 degrees, so we're 30 degrees cooler. And I was saying earlier that I like cooler better for a lot of reasons. Now one reason that 43 degrees Celsius is much better than 71 degrees Celsius, again, is if you have a condensing heater, it will be condensing, which means that it'll be operating above 90% efficiency and delivering this heat. Whereas this one won't be condensing, and so it'll be operating maybe at 60 degrees efficient, or 60% efficiency to deliver the same amount of heat to the same space through a similar looking baseboard. And then, like I mentioned, geothermal, solar can all provide this type of temperature. If you added another baseboard heater somewhere to the house, maybe to one of the bedrooms that you wanted to keep hot, then you could drop your temperature even further, possibly down to 25 degrees Celsius or something like that. And if you used radiant panels, which could be radiant floor, could be radiant walls, radiant ceiling, then you certainly could reduce the required temperature to transfer the same 1 kilowatt every hour into the space. And you could do it at 20 degrees Celsius. So we talked about having a 1,000-liter storage tank on this house. How much usable heat is in that storage tank? The manufacturer says he doesn't want the tank to be above 80 degrees Celsius, so I use that as my upper limit. And then if I say I want to use a slant fin design, I can only bring it down to 71 degrees Celsius, because below that I don't have enough energy in the water to heat the house using that heat emitter. So I've calculated based on 9 degrees Celsius and the thermal coefficients for water, the specific heat for water, that 1,000-liter tank would be enough to heat this house for 0.4 days using the slant fin heat exchanger. If the tank was at 80 degrees and there were no losses, it just went into the house at a rate of 1 kilowatt per hour. Whereas with this Smith's heat exchanger that we have here, a fully charged system should be able to last for 1.7 days. And if they could use 20-degree water to heat the home, then they could heat it for 2.8 days. So they're actually getting more heat out of the system. There's nothing magic. All that heat is still being put into the 1,000-liter tank. Just more of that heat can then be drawn out of the tank. It isn't stated explicitly here, but the converse of this is if we don't have enough energy, not enough thermal radiation to raise the tank to 80 degrees, but if I can only raise it to 50 degrees, I can still provide 1 kilowatt with this Smith's heat emitter, but with the slant fin, if I'm getting 50-degree water, even if I'm getting 1,000 watts an hour solar coming in, I can't put that into the house because the emitter isn't effective enough at that low temperature. So next I looked at the average of what they state on the Weather Channel as the daily high temperature. The reason I took daily high temperatures, the reason I'm looking at these temperatures is to try and estimate how much energy I get out of my solar thermal panel. And I said one of the temperatures I need to know is the ambient temperature. And my thinking is, in January, if we're only getting 3 or 4 hours of sunshine, it's very likely those 3 or 4 hours of sunshine are going to occur during the daily high temperature. So that's how come I pick these numbers. You can see January is -13. Everything else is within -10 or higher. And then, so then if we look back to this graph, I'm saying in order to operate this heat emitter, I wanted it to be, is it 43 or 34?
43.
43 degrees Celsius. And then outside, about -10 degrees Celsius. So that adds up to a difference, the Ti minus TA, of about 50 degrees Celsius. In January, maybe 60 degrees Celsius. So if I look at the 60 degrees, this is the expected amount of heat I can expect out of each of my collectors, which is just over 1,000 watts.